Homework number 4. Identifying function types given graph. This task will review these 6 function types: linear, absolute value, exponential, quadratic, cubic, and square root. As you're reviewing, you'll likely want to look for some hints to help you remember these shapes. Like linear is a line. Absolute value is shaped like a V. Quadratic has a U in it. And exponential gets really high or really low really fast. Since you can't take the square root of a negative number, eventually a square root graph will come to an end point somewhere along the graph. If it has a slight left or right turn in the middle of the graph, that's cubic. Anything with a U shape is quadratic. And you'll continue on and on as such. The second topic is determining whether a table has a linear, a quadratic, or an exponential relationship. So for this one, you'll need to review whether the function is linear, quadratic, or exponential, and the reason why. If it has a first difference and it's constant, that's linear. If it has a second difference that are constant, that's quadratic. And if it has a common ratio of successive y differences, then that is exponential. So linear, common first difference, quadratic, common second difference, and exponential, common ratio. So first, take a look at your table. Make sure that your x's have a constant change, which they do, and then look carefully at the y differences. 7 to 8 is plus 1. 8 to 9 is plus 1. 9 to 10 is plus 1. And if that pattern is continuing, that's called a common first difference. So because it has a first difference, that makes it linear. Let's take a look here. Our x values are constantly increasing by 1. This one here looks like it is increasing by 11, but then this one is increasing by way more than that. I mean, that's a growth of about 77. So there's no way that this is going to have a constant pattern of adding each time. So we're going to go back and we're going to check to see if it has a common ratio. And for most of us, we'll need to use a calculator for this. All right, I'm going to open my calculator here. And how I'm going to calculate to see if I have a common ratio is to go to the second value and divide it by the first. So I'm going to type here 20 divided by 9 and see what value I get. 2.22222. And then I'm going to do it again, moving down the table. So this time I'm going to divide 97 by 20 and see if I get that same value. I don't. So now I know it's not exponential. Since we didn't find any common first difference or second difference, we're going to say it's none of the above because it doesn't have any of those types of patterns. Again, take a look at your x values, make sure that they are increasing by 1 each time, and then in order to check if there's a common difference, if you're unsure, you take the second value and you subtract it by the first value. If you're looking for a common ratio, you're going to take the second value and divide it by the first value. So let me show you that again. Using a calculator, I'm going to take negative 1728. I'm going to subtract it by negative 1296. Notice I have 2 subtraction symbols here in a row. That's because the formula is subtraction and the 1296 has a negative. So there's my difference. Let's do this again with the third value. Negative 2304 subtract negative 1728. Let's see what we get. We don't get negative 432. We'll try this again with the fourth value. Negative 3072 subtract negative 2304. So I definitely do not have a common first difference. So now what I'm going to do is check for a common second difference with these values. So I'm going to do 576 minus negative 432. And then I'll do negative 768 minus negative 576. So here we go. Negative 576 subtract negative 432. That has a common difference of 144. Negative 768 subtract negative 576, and that has a difference of negative 192. So there's no common first difference, and there's no common second difference. So now what I'm going to try is checking for a common ratio. Again, I'm going to take the second value, I'm going to divide it by the first. And let's see what we get. So negative 1728 divided by negative 1296. Okay, negative 2304 divided by negative 1728. It's the same. Negative 3072 divided by negative 2304. Oops. It's the same each time. So this has a common ratio. So we're going to select that it is exponential because it has a common ratio of successive y values. And that's how you look to determine the type of function you have in the table. Now the third topic, all of the tables will be linear, and you're going to turn them into an equation. So I already know that this table is linear. It says it right here. It's a linear function. And what it wants you to do is find the equation of the line. The final answer has to be in slope-intercept form, but that doesn't mean you can't start using point-slope form. That is something that you can do, or you can use a shortcut if you can find these values quickly with your mental math. The y-intercept, or the value of y sub 0, and the slope, also known as the change in the y's divided by the change in the x's. I think we might be able to do this one mentally, so let's give it a try. So the first thing I'm going to do is check my change in the y and my change in the x. So it looks like I have an increase of 5 and an increase of 1. So that means my slope is 5 over 1, or my m value is 5. So my m value is 5. Now, to go back to the table, I'm going to take a look and see if I can't find the y value when x is 0. So right now I don't have a 0 in my table, but I do know if I go back one time here, which is the reverse of the moving down pattern, then all I have to do is reverse the y's pattern. So I'm going to subtract 5. So that makes my b value negative 5. Now when I type it into my answer key, I write y equals, first the slope, 5x, and then the y-intercept, minus 5. And that's it. Again, you have an option to use a shortcut if you can find the slope by looking at the pattern of the table. And remember, it goes in this order. Pattern of the y's, minus 5, minus 5, minus 5, over the pattern of the x's, plus 1, plus 1, plus 1. Once you have that value, you can work your table backwards in order to find the y-intercept. So to work it back to 0, I subtract 1 time, and that means I'm going to add 5. So negative 3 plus 5 is 2. So that makes my sentence negative 5x with a y-intercept of plus 2. Okay. The next topic is the same, but we're going to level up where mental math might not make us able to come directly to the equation. So for this one, it may be a little bit harder since the patterns +2, +2, +2, when reversed, -2, don't get us to that 0 value that we want. So when that's the case, we use our point-slope formula to help us write the equation. In this formula, you do need to know the slope, just like before. But instead of trying to calculate the y-intercept yourself, you simply put one single point into the x1, y1 position. Any point you like. I can choose this one, I can choose that one, I could even choose this one. It doesn't matter. So first I'm going to calculate my slope value. So it looks like my y value is changing by +8. And it looks like my x value is changing by +2. Remember, it's change of the y over the change of the x. And 8 over 2 is a slope of 4. So that number goes here. So I'm going to put it into the formula. And now I'm going to erase and replace these point values with any point that I choose. So I'm going to choose this one. The value that goes here is the y coordinate. That's a 5. The value that goes there is the x coordinate, which is a 1. And now I'm going to manipulate or simplify this sentence. Nothing to do on the left yet. Some distributing on the right. 4 times x is 4x. 4 times -1 is -4. Then I'm simply going to isolate y by adding 5 to both sides, giving me y is equal to 4x plus 1. Let's do this one more time. Using the point-slope formula, and you can look this point-slope formula up on your reference sheet in your notebook. So here we go. You can choose any 2 points to find the slope. So I'm going to choose these 2. It looks like it goes up 16, and over here it looks like it goes up 4. And 16 divided by 4 is 4. So that goes here. And now you can choose any point you want. I'm going to try to avoid the negatives, so I'm going to use this point. So I'm going to erase my x value, replace it with a 1. I'm going to erase my y-coordinate value. I'm going to replace it with a 3. And now I'm going to simplify. Y minus 3 is equal to 4x minus 4. Add 3 to both sides. Y equals 4x minus 1. And that's it. The next topic is going to give you a table that's exponential. When we change a table into an exponential function, we have to use the exponential function formula. And it's slightly different than the linear function. In an exponential function, the initial value goes first. And the rate of growth or change, growth or decay, goes inside the parentheses. And remember, it has to be a multiplication pattern, because this is a multiplication sign. So here's what we're going to do. We're going to find our initial value first by looking at the table and finding when x is 0. When x is 0, that is our initial value. So we erase and replace with that number. Now for the b value, we're going to look here for the common ratio, right? So we have an increase of 1 here, which is good, right? That's the pattern. And what's the timesing pattern on the y's? It looks like it's timesing by 3. So that makes our rate of change here, our rate of growth, as 3. I could write it as 1 parentheses 3 to the power of x, but since this value is 1, I could also simplify it to just 3 to the power of x. But either one will be marked correctly. The y equal sign is already here, so I'm just going to type 3, shift 6 to get to the exponent. And if you don't have a keyboard that can do that, you can always open this Delta Math keyboard and type these exponent buttons here. If it's an exponent of 2, you type this. If it's a different exponent, any one you want, you type a to the b. Alright, again, we look for the y-intercept first, and that will be our first value. And then in the parentheses will be that ratio of how the y's are changing, as long as the x's are going by ones. And if you're unsure how it's changing, you can use your calculator to test by taking the second value and dividing it by the one before it. Right? So I can do 2.5 divided by 5. I can take 1.25 divided by 2.5. And I notice that it's 0.5 each time, also known as a half. So each time I'm timesing by 1/2. You could type it as a fraction, you could type it as a decimal. Either one would be correct. The next topic is writing linear equations using the point-slope form. So just like in the previous lesson, where I talk about using this formula, known as the point-slope formula, you're going to erase and replace the slope and use a single point. So in this question, they ask you to use the point-slope formula. And they ask you to use this point and this slope. They don't ask you to write the answer in a different format, so once we erase and replace these values, we're done. So the slope goes in the M position, and the points go in this order. The x coordinate goes at the end, so that's where my 14 will go. And then the y goes in the front, and that's where my negative 14 will go. Now the only thing I will say is if you have 2 minus signs in a row, that you can simplify that by writing it as a single plus sign. And you can type exactly this sentence into the answer box. Y plus 14 equals 4 parentheses x minus 4. You don't need to do any other, x minus 14. Don't need to do any other simplification or manipulation. That's it. So look up your formula, erase and replace these correct values with the appropriate numbers from the question. So this is a y coordinate. It goes here. This is a slope. It goes here. This is an x coordinate. It goes there. If there are no double signs, you can simply type that response in the answer box in the exact order that you have it there on your scrap paper. To type a fraction, you can use the keypad over here, virtual keypad, or you can use the division button on your keyboard. The next topic is the same, except we're going to add a little extra step. So for this topic, I won't tell you the slope, but I will give you 2 points so that you can calculate the slope. And the slope formula is y2 minus y1 divided by x2 minus x1. And then it asks for your answer in point slope form, which is this format. The only time you don't use that format is if it is an undefined or 0 slope line. Those are some special cases, and they don't have both a y and an x in them. They have a single variable only. So let's take a look at the one we have here. So y2 is -3. And remember, the formula has its own subtraction sign. And the y1 is 7. And the x2 is -2, and the x1 is 7. So here I'm going to get -10 over -9, which is positive 10 over 9. So that's the number that goes here. And for my point, I can choose either one of these points. I can choose this one, or I can choose that one. I'm going to choose this one. And the reason for that is strategic. Both the x number and the y number are the same, so I can't mess it up. I can't put them accidentally in the wrong place. So I'm going to erase my y value, replace it with a 7. I'm going to replace my x value. Whoops, I accidentally deleted that minus sign. Replace it with a 7. And then my slope number here is 10 over 9. I'm going to type that exactly into this answer box. Y minus 7 equals 10/9 quantity x minus 7, close parens. One more time. Calculate your slope. So 5 minus 3 over -9 minus -1. And that gives us 2 over -8, which is -1/4. I think I'll choose this as my xy point. So it's y minus 3 equals -1/4 times x minus -1. Now you can't have two signs in a row, so we're going to make this one a positive sign. And we'll type it in here. All right, let's take a look at this special case scenario. Y minus y over x minus x. And this time, I have a -7 over 0. And you can't divide by 0. And if you didn't remember that, you could test it on your calculator. When you put your calculator on and you try to divide -7 by 0, you're going to get an error. Error, divide by 0. It's not possible. So what we're going to do is we're going to interpret that. Right? If you can't divide by 0, then that is what we call undefined. Undefined, right? Slope dude is going in this direction. That is known as a vertical line. And on that vertical line, you do not have both a y and an x in your sentence. You have an x only. Undefined, right? Remember I tried to help you out? Undefined. So that's slope dude falling to his death. And that means he has an x-only statement. And if he has an x-only statement, then that means that you need to put the x value of the point. And they will always be the same. So the x value is 6. Our answer here is just the sentence x equals 6. No point slope formula needed. All right, let's take a look at our last two, which is determining the difference between an arithmetic and a geometric sequence. Remember, arithmetic is a linear pattern with a common first difference, and geometric is exponential with a common ratio. So they're going to ask you to choose from these drop-down menus whether you think the pattern is arithmetic or geometric, and then they're going to ask you to define why, right? Arithmetic has a common difference, linear. Exponential has a common ratio, exponential, geometric, and then they ask you to put that value. So we're going to take a look here and see, is this adding by 10 each time? No. So that means that it is not arithmetic. And so we tried timesing by 6, and that is the pattern. So we're going to type here that this is geometric because it has a common ratio, and that ratio is 6. One more time. We always try the differences first. -6, -6, -6 is the pattern. So that makes this arithmetic because it has a common difference, and that difference is -6. one last time. This one looks like it is subtracting 8, subtracting 8. So that makes it arithmetic because it has a common difference of -8. All right, last topic, selecting the explicit formula for the sequence. Now don't forget, you do not have to memorize the explicit formulas. They can be found on your Algebra 1 reference sheet right up here for arithmetic sequence and right here for geometric sequence. All you have to understand is what values go into the A1 position and the D position, or what value goes in the A1 and the R position. Remember, arithmetic has a common difference, that's why there's a D, and geometric has a common ratio, that's why there's an R. So let's take a look at the first question. So the first thing we want to know is what type of pattern is it? Is it a common difference or is it a common ratio? It looks to me like these numbers are getting quite large. So what I'm going to do is I'm going to estimate or guess that it has a common ratio to begin with. And what I'm going to do is I'm going to take my second value and divide it by the one before it and see what I get, 5. Now I'll take my third value, 375, divide it by the one before it, and if I get a constant ratio or rate, then I know that this is geometric with a pattern of multiplying by 5. So that is the R value. And the A1 value is the answer in the first position, or 15. The formula is A sub 1 R times the exponent n minus 1. So this value will go here, and this value will go there. So the initial value was 15. The common ratio is 5, so I'm going to put my parentheses in there. And then my n minus 1 will help me to find the answer in any position. So I look at my options. The initial value is 15, so this one is out. My common ratio is 5, so this one is out. And then don't forget the exponent is n minus 1, so this one is out. So we have found the explicit formula for this function. All right, let's take a look here. Seems to be going down. So this one's going down, -30. And this one's going up 15. Okay, so that's not a common difference. So let's see if we can't get the common ratio here. This one is timesing by -1/2, and this is timesing by -1/2. So it looks like our common ratio is -1/2. Looks like our initial value, A sub 1, is 20. And don't forget that the formula, when looking at the reference sheet, the formula has n minus 1 as the exponent. So our initial value, A sub 1, is 20. So this one's out, this one's out. Our common ratio was timesing by -1/2. So these are both in. And then our exponent is always n minus 1 here. So that makes this one the choice. So this one looks like it is adding 7 each time, so that makes this arithmetic. So the answer in the first position plus the common difference times the quantity n minus 1. So my answer in the first position is -3. So I'm going to type that here. And my common difference is adding 7, so I'll put that here. But this one doesn't have the right sign, so that can't be it. And this one is exponential, so that can't be it. And this one doesn't have the right answer in the first position, so that can't be it. So how would I match it to this? And what I could do is, I could distribute these values, then combine these like terms, And that's how I can get this formula. So sometimes you may need to do a little bit more manipulation. But this answer is correct. And that concludes homework number 4.